Let's look at some examples of the uniform distribution, which basically looks like a rectangle, so sometimes it's called the rectangular distribution. In this example, a class typically lasts between 48 and 52 minutes. The probability that class will be dismissed at any point between these two values is 0.25. Shade the graph below to represent the probability of the teacher ending class sometime between 48 and 49 minutes. Now, before we talk about the graph, look down at Lightbulb Man, who reminds us that because the total area under the density curve is equal to 1, and the sum of all probabilities of a probability distribution is equal to 1, there is a correspondence between area and probability. So when you are asked to find the probability in this whole chapter, you're actually also being asked to find the area of a specific region of that graph. If we look at this rectangle, we see that on the far left side of the rectangle we have 48, and on the far right side of the rectangle we have 52 minutes. They all go up to, or they both go up to the point of 0.25, which is the only thing labeled on the vertical axis, because every second in between 48 minutes and 52 minutes has the same probability. So if we go back and on the horizontal axis put 3 somewhat evenly spaced dashes, we could label those 49 minutes, 50 minutes, and 51 minutes. And if we're trying to shade the graph to represent between 48 and 49, then we just go 49 up to the top of the rectangle and shade it in. Now, they're not asking us to find the probability right now. We are just shading what would represent that probability, but we want to just let you see what that looks like. So now let's go to a problem where we actually do the math and find the probability. Same type of picture already on your screen. We've got a rectangle. This time the probability is 0.125. That's the only thing labeled on the vertical axis. And on the horizontal axis we have from 0 to 8. We don't know what the situation is, but we have the numbers. The slide says use the following uniform density curve to find the probability. And the question says, what is the probability that the random variable has a value greater than 6.5? Now remember, it says probability, so we have written out here P of x, parentheses x, because that's our random variable, greater than 6.5. So just like we did on the previous one, if we go over to the chart and we find 6.5, approximately halfway between 6 and 7, and then draw a little line up to the top of the rectangle, since it says greater than, we're going to shade to the right. All numbers are greater than to the right. And what we formed is a rectangle inside of the rectangle. So mine is shaded red. We're going to find the area now of the red rectangle. And again, Lightbulb Man is reminding us that the probability is the same as the area. And down at the bottom of the screen, Lightbulb Man is reminding us that the area of a rectangle is simply length times width. You learned that back in 3rd grade. So what is the length and the width of our small rectangle inside? Well, obviously, if you go straight up the side, you have 0.125. So I'm going to call that the length, otherwise known as the height. And then how do we find the width? Well, if you look at the graph, we're going from 6.5 to 8. So the distance is 8 minus 6.5, or 1.5. Sometimes you'll be able to look at that and subtract it in your head. Other times you may need to put it in the calculator. But think about the distance between the left side and the right side of your rectangle. In this case, 1.5, so we put that in our calculator, and 0.125 times 1.5 is 0.1875. That would be the probability. It would also be the area of that shaded region. I also want to remind you that the full rectangle is equal to a probability of 1. If we go on to the next question, or two questions. We have the same picture, but two different questions. Use the following uniform density curve to find each probability. What is the probability that the random variable has a value less than 3? So we've written probability, parentheses, x less than 3. If you want to stop for a second and shade it and try to find it on your own, you can. Hopefully what you've noticed is that you're going to put a dot on the 3, go up to the top of your rectangle, and because it's less than, we're shading to the left. Again, remember that probability is the same as area when we're dealing with these curves. So we need a length times a width. Again, the length or the height is 0.125. And so what's the width? Well, this time the distance is from 3 to 0. So 3 minus 0 is 3. And we put that in our calculator. 3 times 0.125 is 0.375. And let's do it one more time. Why don't you pause here and see if you can do part B on your own. Okay, so if you're back, hopefully you estimated where 3.1 is. So we're finding the value of the probability, or the probability of the value between 3.1 and 5.4. We're just estimating on our number line on the axis, on the horizontal axis. Draw up to the top of the graph and then literally shade between. Again, we have a small rectangle inside the large rectangle. Our answer will obviously be less than 1 because the whole rectangle equals 1. And so length times width was 0.125. And what'd you get on the width? 5.4 minus 3.1, which is 2.3. And when we multiply that times 0.125, you get 0.2875. So the probability of picking any number between 3.1 and 5.4 is 0.2875.